Hello everyone, myself Bhuvanashri VS. I am currently pursuing my civil engineering in SPC Bengaluru. Today we will be discussing about lug angles, splices and gussets and its advantages and its disadvantages. What are lug angles? Lug angles are structural components typically used to connect and support other steel elements. They are L-shaped sections that provide additional strength and rigidity to joints. Commonly, these lug angles are commonly used in frames, brackets and supporting structures, and lug angles enhance the load distribution. Design considerations for lug angles. When designing lug angles, engineers must consider load paths and forces. The size and thickness of the angles should be adequate to resist the applied loads. Proper welding and connection methods are essential for performance. Advantages of lug angles. Lug angles provide significant structural support and enhance stiffness. They are relatively easy to fabricate and install, and they reduce the construction time. Their versatility allows for various applications across different engineering fields. Disadvantages of lug angles. The addition of lug angles can increase the overall weight of a structure. If these lug angles are not designed correctly, they can lead to stress concentrations and failure. Lug angles may require additional maintenance and inspection over a time. Applications of lug angles. Lug angles are widely used in the construction of bridges, buildings, and machinery. They are crucial in applications requiring high strength to weight ratios. By reinforcing connections, lug angles improve the overall stability of the structures. Lug angles in bridge construction. Lug angles are commonly used in bridge construction to support beams. Their design must account for dynamic loads and environmental factors. Successful implementation enhances the longevity and safety of the bridge. What are splices? Splices are joints used to connect two or more structural elements together. They allow for lengthening of beams, columns, or other components in construction. Properly designed splices ensure continuity in load transfer and structural integrity. Types of splices. There are several types of splices including butt splices and lap splices. Each type has a specific application and requirements based on the load and material properties. Choosing the right splice type is essential for maintaining structural safety. Design considerations for splices. Splice design requires careful attention to load transfer and alignment. The materials used in splices should match the properties of connected components. Engineers must account for potential fatigue and stress over time. Advantages of splices. Splices allow for the easy assembly of long structural elements on site. They facilitate the transportation of large components by breaking them into manageable sizes. Properly designed splices can maintain the structural integrity of the overall systems. Disadvantages of splices. Splices may introduce potential weak points in a structure if not engineered adequately. The installation of splices can be labor intensive and time consuming. Misalignment during splice connections can lead to issues in load transfer. Splices in high-rise buildings. Splices are essential for the construction of high-rise buildings due to their height. Engineers must ensure that splices can handle vertical and lateral loads. Properly designed splices contribute to the overall stability of the structure. What are gussets? Gussets are plate-like structures used to strengthen joints and connections. They are typically triangular in shape and provide stability against lateral forces. Gussets are commonly used in trusses, frames, and bracing systems. Design considerations for gussets. Adequate sizing of gusset is crucial for effective load distribution. The connection details must be carefully engineered to avoid weaknesses. The placement of gussets should enhance rather than impede structural performance. Advantages of gussets. Gussets provide excellent resistance to shear and lateral forces. They can be integrated into various designs without significantly increasing weight. Their use in trusses allows for efficient load distribution and stability. Disadvantages of gussets. Gussets can complicate the design and fabrication process. If it is not properly sized, they can lead to inefficiencies in material usage. Their presence may limit access for inspection and maintenance. Applications of gussets. Gussets are utilized in various structures including roofs, bridges, and towers. They play a crucial role in distributing loads and preventing deformation. The designs of gusset can vary depending upon or based on the specific requirements of the project. Gussets in truss systems. Gussets are integral to the design of truss systems in various applications. They provide necessary support while minimizing the material usage. Effective gusset design can lead to significant cost savings in construction. Conclusion. Understanding lug angles, splices, and gussets is critical for structural engineering. Each component offers unique advantages and challenges in design and application. By carefully considering these elements, engineers can create safe and efficient structures.